Today I am going to do about mode. To understand what is mode, let me give first by an example. So let me list down the marks obtained by students in a test randomly, right? So for an example, let's say the marks will be 1, 5, 1, 4, 2, 2, 7, 4, and then 2. Right? So these are the marks obtained by the students. When you observe at these marks carefully, what do we see? We can see that we can see that 2 appears 3 times. So some of the students, they get 2 marks. 3 of the students got 2 marks, right? And we can see 1 appears only 2 times. 4 appears 2 times, and then 5 only once, 7 only once. So when we observe from here, 2 has the maximum observation here, alright? So this 2, which has the maximum observation, which occur many times here, is called as the mode, right? So that observation which occur many times is called as the mode. Or if we arrange in terms of a frequency distribution table, let's say 1, here 1 appears how many times? 2 times. So these are all frequency and this will be xi. And 2 here appears 3 times. We have 4 appear 2 times, 5 appear only 1, 7 appear only once. And when we observe from this frequency table, what do we observe? The maximum frequency is 3. So this observation which has maximum frequency is called as the mode. So what will be the mode in this case? The mode is 2, which has a maximum frequency. So what is the definition of mode? The definition of mode are those values which occur many times, or we can say are those values which have maximum frequency. That is the values in an observation which occur many times. Which occur most often, or we can say it is the value in an observation having maximum frequency. Maximum frequency. So for ungrouped data like this, it is very easy to find out the mode, because we only have to see the value which occur many times, or we can see that value which has the maximum frequency. Now we will concentrate more on the mode of group data. So in here, to find the mode of a group data, we need to have a table, alright, a frequency distribution table, and we need to know the formula. It is not easy to find directly what is the mode. Alright, first, what is the definition of mode? Definition of mode is the value in the variable which occurs most often, right? And from there we need to concentrate on the model class. What will be the model class? The model class is that class which have the maximum frequency. Class having maximum frequency. So now we will write what is the formula of mode here. formula of mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 whole thing multiplied by H. So what is L? Here L is the lower limit of the model class. L is the lower limit of the model class, and then we'll have F0. F0 is the frequency of the class preceding the model class, and then F1 is the frequency of the model class, right? F2 is the frequency of the class succeeding the model class. Alright, then we have H. H is the class size of the model class. Alright, so how to get the model class? The model class is a class which have the maximum frequency. So we will solve problem by using this formula. Alright, now let us solve one of the problem. Here, find the mode of the following frequency distribution. So this is the given frequency distribution which is given to us. So we need to find the mode of this frequency distribution. We know that in order to find the mode, we need to look at that class which has a maximum frequency. So when we look at these frequencies from here, we can see that 25 has a maximum frequency, right? So the maximum frequency here is 25, then the model class is 26 to 30, right? So here we have maximum frequency is equal to 25, then the class corresponding to this frequency is equal to, the class corresponding to this frequency is 26, 30, 26 and 30. So it means this is our model class. So the model class is 26 to 30. Now from here, 26 is the lower limit of this class. Therefore, L is equal to 26, and then F0. We know F0 is the frequency of the class preceding the model class. So this is our model class. This is our model class. The class preceding this model class, the frequency preceding this model class is 20. So it means this is our F0. F0 is 20. F1 is the frequency of the class. So it is 25. And F2 is the frequency of the class succeeding the model class. So this is F2. This is the frequency succeeding the frequency of the model class. F2 is 22. And H is the size of the class. This is a continuous class. Since it is a continuous class, the size of the class is upper limit minus the lower limit, which is 4. So now let us find the mode. So hence our mode is equal to L plus F1 minus F0 by 2 F1 minus F0 minus F2 whole thing multiplied by H. Alright, substituting the values here, L is 26, F1 we have 25, F0 is 20, 2 into F1 which is 25, F0 is 20 and F2 is 22, and into 4, the size of the class is 4. So this will be 26 plus, we'll calculate first this one, 25 minus 20 which is 5, and then this will be 50 minus 42 into 4, then this is equal to 26 plus 5 by 50 minus 42 is 8 into 4. Now 4 into 2 is 8. We'll have 26 plus 5 by 2 is 2.5. Then 26 plus 2.5 is 28.5. So this is our mode. Alright, this is the mode 28.5 of the given frequency distribution. So I believe you have understood all the steps of this problem. You can solve some more problems for mode by using the same formula. Alright, so what is median? Median is the middle value. Yes, it is that value which divides the distribution into two equal halves. To understand that, let me give by an example. For an example, if we have a data of the form 7, 6, 5, 6, 7, 8, 9. Right? So these are the data given to us and we need to find the median of this data. Right? So it is, since I said that median is the middle value, it doesn't mean that you only have to pick the middle value from this data. You need to follow one step, and that is arrange first the data in ascending order, then pick the middle value. So when arranging this in ascending order, we'll have 5, 6, 6, 7, 7, 8 and then 9. So here what will be the middle value? We can see the middle value is 7. Why it is 7? Because 7 divide the whole data into two equal halves. The first one, it has true data, and the last one also true data. So our median here, it will be 7. We denote median by M. Alright. So if the number of data is very small, it is very easy for us to decide or to visualize which one is the median. But what if the median is, the number of data is huge? For example, 100, 121, 150. It is not possible for us to visualize the median. So what will we do? We have to write some formula in order to know how to find the median according to the number of data, that is whether the number of data is odd or even. So the formula will be, when n is odd, when the total number of data is odd, then our median will be equal to n plus 1 divided by 2 df observation. Alright, and when n is even, our median will be the average of n by 2 df observation and n by 2 plus 1 df observation. So taking the average of these two, you will get the median. Alright. So this is about the finding of median for raw data. But now our focus will be on finding the median about the group data. Alright. Alright. Now we will try to find the median of the group data. In order to find the median of the group data, we need to follow certain steps. Right, so the first step is we need to find the cumulative frequency of all the classes and n by 2. So the first step is find the cumulative frequency, that is CF, of all the classes and n by 2. Right? The second step is, after finding the cumulative frequency and n by 2, now we will find the median class. Which one will be the median class? The median class is that class whose cumulative frequency is greater than or equal to n by 2. So the median class is that class whose cumulative frequency is greater than or equal to n by 2. Alright. So after we have done with these two steps, now you will find median by using the formula m is equal to L plus n by 2 minus C divided by F into H. Alright. Where L is the lower limit of the median class, and then H is the class size or width of the class size, F is the frequency of the median class, C is the cumulative frequency of the class preceding the median class. C is the cumulative frequency of the class preceding the median class. Alright? And n is the total number of observations. So by using this formula, we can now find the median of the group data. Let us solve some problem by using this formula. Alright, so let us solve this one problem here. The question states that find the median of the following frequency distribution. So this is the given frequency distribution to us. And now we need to find the median of this frequency distribution. So our solution will be, again we'll write the table, daily wages here, frequencies here. So according to that steps, first we need to find the cumulative frequency. What is cumulative frequency? Cumulative frequency is nothing but it is the addition of these frequency step by steps. Alright, so the first one, it will remain 5. The next you need to add 5 with 15. Then this will be 20. And again now you'll add 20 with 20. You get 40. 40 now add with 30. You get 70. 70 add with 20. You will get 90. And last 90 add with 8. We'll get 98. So here we need to find n. N is the total observation. N here is equal to 98. Alright. Then the next step, we need to identify the median class. How to identify the median class? We need to find n by 2. Here n is equal to 98 such that n by 2, it will be 98 by 2. So this will be 49. 49. To identify the median class, we need to concentrate on the cumulative frequency, which is greater than 49 or equal to 49. Now have a look at this cumulative frequency. We don't have any 49 here. So the cumulative frequency which is just greater than 49 is 70. Alright, it is 70. Then this 70 lies in the class 90 to 99. Then it means this class will be our median class. Right? So here, cumulative frequency which is greater than or equal to 49 is 70, which lies in the class 90 to 99. So it means our median class will be this 90 to 99. Therefore, median class equal to 90 to 99. Now we will list down the terms used in the formula. L will be the lower limit of the median class. So L is 90. And then F is the frequency of the median class. Frequency of the median class is 30. It is 30. C is the cumulative frequency preceding the median class. So this is our median class and the cumulative frequency preceding this class is 40. So C is 40. H is the size of the class. So this class we can clearly see it is a non-continuation class, right? So the width of the class will be, start counting from 60 to 69, it will be 10. H is equal to 10. And then N is 98. So now let us try to find what will be our median. So therefore median, using the formula, it is L plus N by 2 minus C divided by F into H. Substitute the value here. Our L is 90 plus N by 2 is 49 and our C is 40, F is 30 and H is 10. Alright, here this will be equal to 10 can cancel with 30, then plus 49 minus 40 is 9 by 3 and again here 3 into 3 is 9. So you will have 90 plus 3 equal to 93. Right. So this is our median of the given frequency distribution. So there are still lots of problems in the exercise. You can practice some more by following the same procedure. Alright. This is the end of the chapter for statistics. I encourage you to solve some more problems from the exercise and to go into details from the textbook. So study hard, stay safe, take care.